You already know the names. You heard them mentioned once briefly in passing: Bloop, Julia, Slowdown, Train, Upsweep, Whistle. 6 names, 6 sounds recorded by a network of underwater microphones that the United States government originally built to track Soviet nuclear submarines during the Cold War. 6 sounds that NOAA's scientists detected, catalogued, named, and then explained. Officially. This video is about what the explanations don't account for, not what they get wrong, what they leave out. The gap between what was recorded and what was said about the recording. Because there is a pattern in that gap, and the pattern is not reassuring. Before we go into each sound individually, you need to understand the instrument that recorded them. SOSUS, the Sound Surveillance System, is a network of hydrophones anchored to the ocean floor at depths specifically chosen to exploit the SOFAR channel. The SOFAR channel, a layer of water at roughly 600 to 1,200 meters depth, where temperature and pressure combine to create a kind of acoustic highway. Sound entering the SOFAR channel doesn't dissipate the way surface sound does, it travels. It travels vast distances with almost no loss of energy. A sound produced on one side of the Pacific can be detected on the other side. A sound produced in Antarctic waters can be picked up by sensors in the North Pacific. The geometry of the ocean itself acts as a waveguide, and SOSUS was built to exploit that. When NOAA began civilian monitoring through the SOSUS network in the early 1990s, the scientists described the experience as suddenly being handed ears that could hear the entire ocean at once. They began detecting things they had never heard before, sounds with no entry in any catalog. Sounds that didn't match whale calls, didn't match geological signatures, didn't match ship noise or military exercises. They gave those sounds names, and then they offered explanations. Here is the first one. The bloop was recorded on the 9th of May, 1997. It lasted approximately 1 minute. It rose rapidly in frequency, the characteristic shape that gives it its name on a spectrogram, that sudden upward sweep. It was detected simultaneously by hydrophone stations more than 5,000 kilometers apart. Something producing a signal loud enough to be picked up across 5,000 kilometers is producing an enormous amount of acoustic energy. The scientists who first analyzed it noted that the profile, the way it rose in frequency, the modulation pattern, the duration resembled biological sound production more than geological events. NOAA's official explanation, issued years after the initial recording, was that the bloop was almost certainly an icequake, a large iceberg fracturing, either cracking internally or calving from a glacier. Between 2005 and 2010, NOAA tracked iceberg A53A as it disintegrated near South Georgia Island. The spectrograms of that event matched the bloop's profile closely enough that NOAA used it as the basis for the icequake attribution. The icequake explanation may be correct. Here is the question it doesn't answer. NOAA's own researchers have stated that icequakes similar to the bloop occur tens of thousands of times per year in the Southern Ocean. Icebergs continue to fracture, glaciers continue to calve. The conditions that supposedly produced the bloop in 1997 have been present every year since. And yet, in nearly 30 years of continuous monitoring, no sound with the specific acoustic signature of the bloop has been recorded again. Not once. If the bloop was an ordinary icequake of a type that occurs tens of thousands of times annually, the probability of it never recurring across 3 decades of sensitive monitoring is not comfortable. The explanation names the category. It doesn't account for why that specific event has remained singular. The icequake explanation was not accompanied by a press conference. It appeared in a written update on NOAA's website. The specific acoustic features that made every scientist in that room stop were not addressed one by one. The sound was moved from the unexplained column to the explained column. Its administrative status changed. The question of why it has never sounded again did not move with it. Julia was recorded on the 1st of March 1999. It lasted approximately 2 minutes and 43 seconds. The Eastern Equatorial Pacific Autonomous Hydrophone Array, the full array, every sensor across the Pacific, detected it simultaneously. Julia was extraordinarily loud. The sound rose in pitch and then descended in a long, slow curve. No, researchers who first heard it noted the tonal quality, something in its shape unusual enough to give it a name referencing a human voice, not words, not language, a quality. The official explanation is that Julia was a large iceberg running aground off the coast of Antarctica in the region between the Bransfield Strait and Cape Adare. Iceberg grounding is a documented acoustic source. It is real, it is recorded, it has a known profile. What the explanation for Julia did not include was satellite confirmation of a specific grounded iceberg at a specific location on the date of the recording. It referenced general iceberg activity in the Antarctic region during that period. General iceberg activity in the Antarctic during austral autumn is not a specific confirmed source for a specific sound on a specific date. The sound rose and fell in a smooth tonal arc across nearly 3 minutes. The explanation identifies a category of source. It does not identify the source. No coordinates, no confirmed mass, no satellite imagery of the specific event. The arc is still in the recording. The source is still unconfirmed. Now pay attention to what happens next, because it matters. Upsweep is different from the others in one important respect. It began before the others, or rather, it was already present when listening began. When NOAA started civilian monitoring in the early 1990s, Upsweep was already in the data. It wasn't detected on a specific date as a discrete event. It was simply there from the first day of recording. A long train of narrow-band upsweeping sounds, each lasting several seconds, repeating at intervals loud enough to be detected throughout the entire Pacific Ocean. The United States Navy had been operating SOSUS for decades before civilian access was granted. In all that time, across all those years of listening, Upsweep had not been logged in any way that made it into the civilian record. The Navy's position is that military monitoring focused on signatures relevant to submarine detection and other sounds were not systematically documented. It also means we don't know when Upsweep started. We don't know if it was there in 1985. We don't know if it was there in 1970. We have data from the early 1990s onward, and in all of that data, it is present, consistent, and unresolved. The official speculation is that Upsweep originates from underwater volcanic activity near 54 degrees south, 140 degrees west, a remote stretch of ocean between New Zealand and the southern tip of South America. That location is associated with inferred volcanic seismicity. The word inferred is doing significant work in that sentence. There is no confirmed active volcanic structure at that specific location. Upsweep is seasonal. It peaks in spring and autumn every year, reliably. NOAA has offered 2 possible explanations for the seasonality. Either the source itself changes seasonally, or the acoustic propagation environment changes with the seasons. Both explanations are technically possible. Neither has been confirmed. The sound continues to this day, declining in overall level since 1991, but still there every spring, every autumn from a location where no volcanic structure has been directly observed. NOAA's own page on Upsweep states 4 words that are easy to miss. The origin is unresolved. Not explained, not attributed. Unresolved. Drop a comment right now, write the word signal, because I want to know how many people are watching this and understanding what's actually being described, not mystery for its own sake, but a documented pattern of sounds that were given explanations without having their specific features accounted for. We have 3 more to go, and they follow the same pattern. Slowdown was recorded on the 19th of May, 1997. It lasted approximately 7 minutes. A sound that begins at one frequency and descends slowly, continuously, over 7 minutes to a lower frequency. Sensors nearly 5,000 kilometers apart detected it. The official explanation is that Slowdown was produced by a large iceberg grounding against the Antarctic seafloor, an iceberg decelerating as its keel made contact with the ocean bottom. That mechanism is physically coherent. An object slowing down by friction can produce a descending frequency. The problem is what the explanation was not accompanied by. NOAA did not publicly release a detailed acoustic comparison between Slowdown and other documented iceberg grounding events. The explanation attributed a category of source. The specific acoustic features were not analyzed publicly against that category. A large iceberg making hard contact with an ocean floor over a 7-minute period involves significant mechanical force. Force of that kind, applied to the seafloor, typically produces detectable seismic signal in addition to acoustic signal. No seismic event corresponding to Slowdown's source location and timing was publicly associated with the explanation. The explanation exists. The supporting seismic record was not presented alongside it. That absence is not proof of anything. It is a question that was not answered, and in the documentation surrounding Slowdown, it remains unanswered. Train was recorded on the 4th of March, 1997. A quasi-steady signal at approximately 32 to 35 Hz, a low, consistent hum, narrow in frequency, persistent enough to earn a name referencing the steady rhythm of wheels on track. NOAA's official position is that train was most likely generated by a large iceberg grounded in the Ross Sea near Cape Adare, with the sound produced by the iceberg's keel slowly moving along the seafloor. Cape Adare is a documented source of cryogenic acoustic signals. Geographically, the explanation is plausible. What makes train acoustically distinctive is the narrow bandwidth of the signal. Friction events, ice against rock, typically produce broadband noise. Irregular contact between two large rough masses generates energy across a range of frequencies simultaneously. A narrow band signal is more consistent with a resonant process, a structure vibrating at a specific natural frequency, than with simple friction. Large icebergs can resonate under specific conditions of size, shape, and contact that is documented. What NOAA's explanation did not include was a description of the specific resonant mechanism that would produce train's narrowband profile from an iceberg of a specific size and geometry. The attribution was made. The acoustic mechanism was not publicly detailed. The signal sits in the archive at 32 to 35 Hz. The specific physical process that produced it at that frequency with that consistency has not been formally described. Whistle is the most isolated of the 6 sounds and the one for which NOAA's position is clearest and most limited. It was recorded on the 7th of July, 1997, by a single hydrophone, the Eastern Pacific Autonomous Unit, at approximately 8 degrees north, 110 degrees west. One sensor. No triangulation, no confirmed source location, no second reading. The acoustic profile is an undulating single frequency, a tone that varies slightly in pitch across its duration. NOAA notes that the whistle resembles volcanogenic signals previously recorded from the Mariana Volcanic Arc, a chain of active underwater volcanoes in the Western Pacific. The resemblance is noted. The problem with it is distance. Mariana Volcanic Arc is in the Western Pacific. The hydrophone that detected whistle is in the Eastern Pacific. The distance between them is approximately 10,000 kilometers. A single-station detection at that distance, with no corroboration from any intermediate sensor, raises a question the explanation doesn't address. Was the source far away and very loud, or was it closer to that hydrophone and simply not positioned to reach any other sensor in the network? If the source was closer, it was in a location where no other hydrophone was positioned to receive it, and no source at that location has been identified. NOAA's official position on the whistle is explicit. The source could not be determined due to single-station detection. Not speculated, not attributed, could not be determined. It was recorded once in nearly 30 years of continuous monitoring. It has not been heard again. Here is what you're left with when you lay all 6 sounds next to each other and look at how they were handled. 4 of them, Bloop, Julia, Slowdown, Train, are officially attributed to ice. All 4 attributions are geographically plausible. All 4 have precedent in documented phenomena. And for each of the 4, something specific was left unaddressed. Why the bloop has never recurred, despite conditions that supposedly produce it tens of thousands of times annually. Why Julia's explanation carries no confirmed satellite source. Why Slowdown's explanation was not accompanied by the seismic corroboration that such an event should produce. Why Train's narrow bandwidth was not explained in terms of a specific resonant mechanism. One of them, Upsweep, is speculated to be volcanic from a location where no confirmed volcanic structure has been directly observed, producing a seasonal pattern that has continued for over 30 years without a confirmed source. One of them, Whistle, has no attributed source at all. The official position is that it could not be determined. All 6 were recorded by the same network within a short window of years. All 6 came with explanations that arrived after the initial recordings, without detailed public technical analysis. This is the pattern. Not that the explanations are wrong, not that the sounds are proof of anything unknown. A sound is anomalous enough to be named, to be logged, to be published as unexplained. Then an explanation is offered that moves the sound from the unexplained column to the explained column. And the specific acoustic features that made the sound anomalous in the first place are not addressed one by one. The bloop's singular non-recurrence, Julia's unconfirmed source location, Slowdown's missing seismic corroboration, Train's unexplained bandwidth, Upsweep's unresolved origin across more than 3 decades. The whistle, which could not be determined and has never sounded again. These are not arguments for undiscovered creatures or classified programs. They are a simple observation about how the documentation works. The explanations change the administrative status of the sounds. They did not fully resolve the sounds. The archive is publicly accessible. The data is there. The gap between what was detected and what was explained is documented, and the documentation is not classified. We built SOSUS to listen for threats we understood. We inherited it and started hearing things we didn't. We named them. We offered categories. We moved on. The ocean did not move on. The hydrophones are still down there, still anchored at depth in the SOFAR channel, still recording the low frequencies that cross entire ocean basins without losing energy. Somewhere in that data, right now, there are sounds that have not yet been named. Not because the network isn't listening, because no one has decided yet what those sounds are. And somewhere in the archive, there are sounds that were named and explained and moved on from that still carry in their recorded acoustic signatures a feature that the explanation didn't account for. The hydrophones hear everything the ocean produces in the frequency range they're designed to detect. What produces those sounds, at what depth, and what it means for the boundary between the deep ocean and the world above it, that is still being decided. We're going into that next. The displacement events, the data on what is moving through the deep water columns. The evidence that connects what the hydrophones record to what expedition cameras occasionally catch at the edge of their range before the footage gets filed. It gets less comfortable from here. Subscribe and turn on notifications, because the acoustic record is one layer. What's moving through the water to produce it is another.